Alright, lesson 2.7C, derivative of log functions. For the derivatives of sine and for the derivative of e to the x, we kind of proved it. Now we're just not going to prove it as much as I'm just going to give you what the derivatives are, and you need to memorize them. If y equals ln x, then what's the derivative of natural log of x function? It would be 1 over x. Put it into practice. If you have, what would be the derivative of 5 times ln x? Well, 5 is just a constant, leave it alone, and the derivative of ln x is 1 over x, which would be 5 over x. Let's go to, if we got y equals b to the power of x, that's an exponential function, then what's the derivative of an exponential function? The derivative of an exponential function would be whatever it is, b to the power of x times the natural log of the base. All right, so that would be that. So how do we put this into practice? What's the derivative of 2 to the x? It would be 2 to the x times the natural log of the base, which base is 2. d dx of 2 times, 2 to the power of sine x. This is a little more complicated. It would actually, the derivative of b to some u, b to the power of u, where u is another function, it would be then b to the power of u would be b to the power of u times ln b times the derivative of u prime, the derivative of that power. This is a lot going on here. So it would be then 2 to the power of sine x times the natural log of the base is 2, times the derivative of this, which is u. The derivative of sine x is cosine x. A lot going on here. It's called the chain rule. We'll do more of this in chapter 3. If y equals log base b of x, then dy dx is going to be 1 over x times natural log b. So putting it into practice, what would be the derivative of log base 4 of x? It would be 1 over x, you see that 1 over x, times the natural log of the base, which is 4. When x equals 2e and we have a limit definition, what would be the answer for this? Well, we have to do it the way we've done before. If we are able to extract the function from here and then evaluate it at this point, that would be the easiest way to go. And from what we've done before, we usually get it from here. You see that it's going to be an ln x function, is f of x, evaluated at x equals 2e. So we just got to take the derivative and evaluate it at 2e. F prime of x is equal to 1 over x. Then it's been evaluated there. So it's going to be f prime at 2e. Just plug it in for x, 1 over 2e. We're done. 13. If f is the function given by this, what's the equation of the tangent line to the graph of f at the point 3 ln 4? 4. So what is it looking for? Tangent line equation. What are we going to do? We always do y minus mx minus. We're given the input, minus 3 ln 4. We're given the output, 4. Got to figure out what the slope is at that point. Let's get the function. F of x is equal to e to the x over 3. We take the derivative and evaluate it at that point. F prime of x is equal to e to the x over 3. Then we take the derivative of this, which is 1/3. And now we're going to evaluate it. F prime at what is 3 ln 4? 3 ln 4. So we got 1/3 e to the x is 3 times ln 4 over 3. Continue, we got 1/3. Well, 3 and 3 cancel out. And then we got e to the ln 4. E and ln cancel out. So we got 1/3 times 4. And so now we got 4/3. And so that is the rate of change that goes here. All right, and we're done.